Hi everyone. Today we are gonna look at one more LeetCode problem. It's called unique pass. And this kind of problems are really my favorite because you will see what technique we are using. We will use recursive method and also a little bit the idea of dynamic programming or we can call memoization. Let's read the problem description. And it says that there is a robot on MN grid. The robot is initially located at the left corner as we see. So grid has MN size, so I think this side is M, number of rows and number of columns is N. And robot can move only in two directions, either down or right. So it cannot go to the left or it cannot go to the up if there is any place to go. So now the problem is that we need to find the number of the unique passes that robot can land on this finish line or finish cell. So like if we roughly think about before we dive into how to solve this issue, we can think that okay, robot can go like this, like this, or like this, so many different ways, right? Even like in this small grid there are so many possibilities like this. So you get the idea. So we need to find number of unique passes the robot can take to reach to this finish line. So I will remove this, and we can think this grid as we know that like we can express it with two index I and j, and we can say that okay, I is the number of the rows, I mean the row index, and the j is column index, and this point is 0 0 for this example. Here is 2 6, so I is 2, j is 6. And the condition has been given us in a way that robot can move down or to the right. So that means that at each point, at every step, robot can either go here or here. So what does this arrow mean programmatically? Going down, if robot goes down, it will be I plus 1 because that is the row index. But index j will stay as it is. So because we only increase row, because we only change row, and the column stays the same. And what if robot moves to the right with the same logic? I will stay as it is because we only increase column this in the same row. So you get the idea. So these are important points to understand this task. And now before we move to coding, I wanna explain you one more concept that's called memoization or dynamic programming. They are all like almost the same concept. So what does it mean? It means that in this grid, we sometimes will go from the same cells. So what does it mean? It means that, for example, let's continue this one. Robot will go to this line, will go to this line, and will go down, just as an example, like this, and then it will end up here, right? So for this cell, we found one way, and then we will continue to go with the different ways, for example, or coming here and going down and then here. Anyway, we will find that from this cell, for example, number of the unique passes to go to this cell will be, just as an example, 8, right? Then when we come to this cell from the different direction, we don't need to calculate that number of unique passes again because we know that it is 8. So we can just add that 8 to the already calculated number of the passes. So what does it mean? That if we use memoization, we can already use the values that we have calculated before. If we end up in the same cell, we will use that pre-calculated value. Now let's start with coding. And first we need to have one static recursive method. So we can call it like move, maybe. And what it will accept as, for now we will say that it will take n, which is the size of the grid, number of rows and the columns, and current index I, row index, and current index j, column index. But there is also one thing that we said, that memoization. And for that we will use two-dimensional array, and that's obvious why, because we have two-dimensional grid. So we will just call it maybe memo to make it clear, and the size will be exactly the same size with grid. So that is why we will have one more argument here for memoization. That's it. Recursive method signature will be like this. Actually, I hope it will be very clear for you after the explanation on whiteboard. If you have worked with recursive methods, you already know that we need to have a base scenario, and also the conditions that will handle edge cases. So what is the edge case? Edge case is that the robot can go beyond the grid. So what is the beyond grid? We don't care about negative values, because it cannot move like a backward, or it cannot move up. It can only move down and right. So we don't worry about negative values. But beyond grid means that it can go beyond the grid's size. So it means that if I is greater than m, or j is greater than n, that means that it is beyond the grid's border. And why we put equal here? Because when we say that, for example, m is 3, and it means that it has 3 rows, but I starts from 0, so that is why I can go only until 2, even m is 3. Okay, perfect. Now we have this edge case handled, so the rest is not that difficult. When we are saying that robot ended up in finish cell, it is when I is equal to m minus 1, j is equal to n minus 1, because it is just right down corner. So that's why we will write that condition. If I is equal to m minus 1, and at the same time, of course, j is equal to minus 1, that means that we ended up at finish cell, so we can return 1. Okay. It means that why we are returning 0 here and here 1, because here it means that we do not increase the count for unique passes, because we ended up beyond the grid, and here we increase it by 1, and you will see how. That's why we return 1. And if it is none of these cases, what can happen? The robot can be in the middle of the grid somewhere, right? We don't know where, but we will check first. We know that when we are creating two-dimensional array, or like one-dimensional array, it doesn't matter. If it is int type, the values will be 0, right, by default. So that's why we are checking if the values are not, if the value at a specific cell, which is like I and j, is greater than 0, that means that we already have been on that cell and we have calculated everything, every unique passes from there, right? So we know what is the number of unique passes. So that's why we will just return that number from here. So we don't need to calculate again, right? So that was the whole idea of memoization or dynamic programming. And here I have one mistake. Instead of int, of course no type, but I will need to write the name of the array variable. Okay, last step is, if we don't have any value in our memoization array, that means that we haven't been there. So we can go in every direction from that cell and recalculate. We can go on every direction, we can go at every direction from that cell, and we can calculate the number of unique passes. So for now, forget about memoization. Let's say that if we want to move down, so we will m and n stays the same, we will only increase row, right? Because we go down, column stays the same. That's it. And how we move to right, row stays the same, only column increases by 1. So but the number of unique passes is sum of this, right? Because from each cell either we can go down or to the right. So we sum them up, and after we have the value from recursive function, we can easily assign it to this memoization array, and we can return memoization array value for that specific cell. So what it will do, instead of like returning this sum from the method, we will save it, we will store it in our memoization two-dimensional array, and we will return that two-dimensional array value for that specific indexes, of course. So that should be all. The only thing that's left is to call this method with arguments. So start point is I0, J0, because that's the first cell, top left corner, and memoization array. So let's run it, and let's hope that we don't have any syntax error. So I will minimize this window so we can see the test results. So case 1 and case 2, both of them has passed already. So we can submit and see if we will get any timeouts, because usually for this kind of solutions we should get timeouts if we don't use memoization, but now we don't because we have used memoization. So if you see, it is 0 millisecond and it beats 100% of the solutions. That was it for today, guys, and if you like these videos, don't forget to subscribe and turn on notifications. That will support me making videos for you. Take care. See you in the next video.